like perfect.
No, Vanessa Conrad came up and she did not say and encourage, which is like a whole line. She just said, I will maintain purposes.
And then she asked if she could say it again and
No.
she walked away.
She did
All
not,
right,
she did not
let's
say it
get
again.
started. So we have our notes that we have been working on the last few days.
Yeah.
Do you want to join us today?
Oh, yeah.
Okay. Have you watched any of the videos from? That's trying not to make a lot of sense.
He went, He still got that golden retriever smile happening.
Okay.
No.
All right. So we have a rock thrown upward on Mars with a velocity of 10 meters per second, and the height is given by this equation. Find the velocity of the rock after 1 second. Okay, we know velocity is,
At point A, given time.
okay, I'm asking for an instantaneous right now, because I want the velocity at a given point in time, which means I have to do a limit.
Is it limit at t approaches 1?
It's a derivative.
So,
The derivative is the same as the slope of the tangent line.
yeah. All right. Oh, hold on. Let me give you the other calculator because you need it for the lines.
I have one question.
Okay, so we have two different definitions for the limit, but we're kind of gravitating towards the one with H's because it is a lot easier. So remember that one is the limit as H approaches 0 of f of A plus H
And A is
minus f of A all over H. So that's just our straight definition. Now the A in this case is 1. But why don't we actually can we do part B first? Is that okay?
Yeah.
Because part B wants a formula in terms of A. So let's do that and then we'll find the velocity at a given point in time so we don't have to redo it. Okay?
sure.
So I'm going to do part B first. So the velocity at time A, we're just doing this limit. So the limit as H approaches 0. F of A plus H says you go to your equation. We are replacing in this case the T's with A plus H. Minus F of A, so 10A minus 1.86A squared. Sorry, I ran out of space.
Wait, I gotta rewrite this. What?
Over H. Okay. So I am distributing. So this becomes 10A plus 10H. Okay, this one. The A plus H squared would turn into A squared plus 2AH plus H squared. Can I go ahead and distribute my negative 1.86 through there?
Yeah.
So minus 1.86A squared minus 1.86 times 2.
Wait, are we not plugging the A in?
No, I said I'm doing part B first.
I heard that, but then I moved.
Oh, yeah.
Okay. H squared times A 1.86 be negative 1.86H squared. Then we have our minus 10A plus 1.86A squared all over H. Okay. Positive 10A and negative 10A cancel. Negative 1.86 and positive 1.86A squared cancel. What do you notice about every term we have left on the top?
They have an H.
Okay, so if we take an H out of everything, that would leave us 10 minus 3.72A minus 1.86H. And if you plug in 0 for your H, you get 10 minus 3.72A. so that was actually part B. We found a formula for velocity. So for part A, once the velocity after 1 second, so you can just plug in a 1.
It was completely on purpose. I cannot stand calc students.
That's for A, right?
Yeah, it's been knocked twice.
Did you tell them about it today?
Told him yesterday.
No, Aiden.
Okay, so we get 6.28 meters per second. All right, C. I want to know, when will the rock hit the surface? That's not asking for the velocity. If it hits the surface, what does that mean?
H is 0.
The h is 0. So I am just setting the original, the 10t minus 1.86t squared equal to 0.
I'm just setting it.
So I know if it hits the surface, that means the height is 0.
Okay.
Okay, we can factor out t, so then if you set them equal 0, you get t equals 0, and minus 1.86t equals 0. It doesn't work out beautifully, but let's say 5.38. Okay, which one of these would it be? I got 0 and 5.3.
The second one.
5.38.
Why is the first one 0?
Because that's when it
Because that's
starts.
when it's.
Right. At time 0, it was on the ground because we hadn't thrown it yet. Then we threw it and it came back to the ground after 5.38 seconds. So then part D, what's the velocity when it hits the surface?
Plug that 5 point nonsense into the equation we found at B.
Yes, in part B, we found an equation for velocity. Plug in our time.
Negative 10 seconds. Doesn't sound right. Oh, because it's going down.
Why? So why is it negative?
It's slowing down when it hits the ground.
Yeah. Velocity is just speed with direction. So the negative is saying it's coming downward.
Yeah, it's speeding up as going down. That's why it has to be the two. Yeah. Oh, Angela's out of physics. It's me and Kate.
Physics kids. We were
Oh,
physics kids.
we're physics now. Oh, we're the current, the region,
graduated from
the better physics kids.
Let's try this problem.
I don't want to.
Well, we're going to.
Wait, we're trying to find the derivative,
This one
or
is
what are we
Yes.
trying to do?
So these are where we picked up yesterday, example 8, we were finding the f prime of a on all of these. I did a and b. Yesterday I want to do this one, and then, I don't know, we'll do another example if we need to, otherwise we might stop and just let you guys work. So, we are doing f prime of a, so that's the limit as h approaches 0 of f of a plus h minus f of a all over h. So that's the definition. That's what we have to work out here. So you need to know that definition. So I have the limit h approaches 0. F of a plus h. So I replace my x with an a plus h. So that'd be 1.
Minus a plus c.
Can I go ahead and write it as 1 minus a minus h?
Ooh.
Because the negative would go through to both terms.
Yeah.
Minus f of a, so 4 over square root of 1 minus a
We don't have to
over
get our
h.
denominators the same.
Common denominators with radicals. Like, can life get much better? This is so
I'm
fun.
already living the dream here.
So first one needs a square root of 1 minus a. Second one needs a square root of 1 minus a minus h. So we get 4 square root of 1 minus a minus 4 Can I go ahead and write these in one fraction?
Yep.
Can we just square the whole thing?
No.
Why?
Because that breaks all the rules.
I don't care about the rules.
Why is that a rule?
Yeah, who made it? Who said we can't?
Okay, if I take 2/3
No, wait, never mind, never mind.
and I square top and bottom, does that still equal 2/3?
No, doesn't
No,
it simplify
so
back
we
down?
can't do it.
No, because
4/9 does not reduce back to
that's
2/3.
silly and
It's legal to multiply by the same thing on top and bottom.
They should fix their numbers.
Because if I multiplied by 2, for
Do
instance,
we multiply by the conjugate now?
so 3 times 2 gives me 4 6, that still reduces to 2/3. So that's why it's legal to multiply on top and bottom, but not to square on top and bottom.
Oh, this is so fun.
Alright, so let's take a look at where we are at. We have a fraction in top, the bottom is over h, or we think of that as h over 1. If we want to divide fractions, we have to multiply by the
You
reciprocal.
gotta do square root of h squared. Get that h to get rid of the other one.
Or do we just multiply by the?
Am I thinking too
Reciprocal.
hard?
Oh,
Am I
If
thinking
we were
too
doing
hard?
it the limit at infinity, that would be
yeah, now we just have to do the top part and do the conjugate. Yeah.
So we're just doing that.
Oh, I'm locked.
Okay,
I'm not.
Oh.
so
I'm 15
we
cents
do
ahead.
have an option. If you want to make it just a touch easier,
You got that 4.
let's take out our 4. So we would have 4
Oh,
is the
that-
square root of 1 minus a minus the square root of 1 minus a minus h. We already said if I wanted to take it divided by h over 1, that's the same as times 1 over h. So could I just throw that h on the bottom here with that?
Okay.
Alright. So,
Why would we do that? How did it end up there?
if you are dividing fractions, that means you multiply by the reciprocal. So dividing by h is the same as times 1 over h. You multiply the
Okay, so
tops.
that H is just gonna be,
Alright, so at this point, if we want to get rid of all these radicals, we have to do the conjugate. 1 minus a plus 1 minus a minus h. Okay. So, it's not pretty, but this is just an algebra problem, and we can handle that. We have the 4. If we FOIL, the square root of 1 minus a times the square root of 1 minus a, minus, because they're conjugates, outside and inside cancel. I got distributed the negative unit, but yes. Okay, the bottom, we can work on multiplying all this, but I don't really want to. So,
Good.
I'm just
glad.
going to leave it all
Thank you.
multiplied together.
Well, I guess I already did it.
what?
I don't know how we're gonna get the answer.
Okay.
Put it in. Did you?
So, on the top, we distribute that negative. Then my 1 and negative 1 cancel, my negative a and positive a cancel. So we have the limit as h approaches 0. Top, all that's left is a 4h. The bottom, we have h times the square root of 1 minus a times the square root of 1 minus a minus h times the square root of 1 minus a plus square root of 1 minus a minus h.
Wait, why does that h not go with everything?
I'm not sure what you mean.
Like, why did the h only go to the first one?
It's all a big multiplication problem.
Oh,
I just
gotcha.
haven't multiplied it out. Okay, so then what happens?
H cancels.
Okay, so now if I put in 0 for all of my h's, I have a 4 on the bottom. Square root of 1 minus a times the square root of 1 minus a because we plugged in the 0 for your h's. We did.
Oh, H's, okay.
Okay, square root of 1 minus a times the square root of 1 minus a is just 1 minus a. Radical 1 minus a plus radical 1 minus a is 2 radical 1 minus a.
Foil. No, just distribute.
And we could even, can you reduce the 4 and the 2 since it's all one big multiplication problem?
Mm-hmm.
Yep. 4 divided by 2 is 2. There are different ways we could write it. You could think of this, that's 1 minus a. A square root is like 1 minus a to the 1/2 power. If you're multiplying those, what do you do with your exponents? So 1 plus 1/2 is 3/2. So I'm going to leave it as 2 over 1 minus a to the 3/2 power. Not the only way you could write your answer, but it will work. In the past, we would have said it's poor notation to leave a radical on the denominator, and it is, but we are eventually going to be doing more than one derivative. We'll do like a second derivative and so forth, and it's easier to keep the radical on the denominator if you're going to have to do another derivative than it is to move it to the top. So I'm gonna allow that for now. If we have a radical on the denominator, we're going to be able to leave it there.
What's the derivative of the derivative?
The second derivative.
Oh, is
That's
that
actually
really what
a
it
thing.
is?
That's
I'm
terrible.
gonna
How
cry.
many derivatives?
I regret speaking.
As many as we want.
We want one.
We just want to use all the paper.
Don't worry, we'll learn some helpful shortcuts.
Helpful
But you
tips.
have to
After
earn
we
them.
do the long one.
We'll
You have
learn
to
mouse
earn them.
control. We have to earn them.
Yes.
Then we'll get a mouse control.
Yes.
Do sweat water.
There's a mystery mouse control right
It's the
now.
mystery mouse tool. You don't know about it yet. It's coming. All right. Why don't we stop? The other examples aren't anything new. It's just more practice. So I want to give you guys time to work and ask questions. So 2.7 we are now done with, which means this assignment is due tomorrow.
Not today.
We will start 2.8 tomorrow. Is everyone going to be here tomorrow except Carson?
I'm donating blood.
Okay.
During this hour.
Why would you do that?
Because I have to have the latest one or else my iron just isn't high enough. And I didn't think, for some reason my brain did not